Hello. So here I'll be providing a solution to a worksheet, and the title of the worksheet is a worksheet for set intervals and absolute value. I will begin with question number 5. Now, question number 5 is the intersection and the union of an infinite set, or you can say of interval. So what do we have? We have from minus infinity to 3, and we want to find the union between these two sets, right? So what can we do? To answer this type of question, we need to draw our lines. So we will have the number line. Now, what numbers do we have here? We have minus 3. So we can say this is 0. And then we have minus 3, we have 1, and then we have also 3. All right. So, but also we should take note that we are actually looking for the union, not the intersection. So we will answer both. So where is 1? If this is 0, so 1 will be somewhere here. Let's say this, I can say this is minus 3, and then I can say this is 1. It's okay. So for the first interval is from minus infinity, so it means you are coming this way. And then we're going up towards 3. So we need to have 3 somewhere here. So let's say this is 3. And then this is open. So we're done with the first set interval. Then the second interval, it's from where? From minus 3. So that will begin from here, but it is closed. But minus 3 now, you'll go up to where? Up to 1, which is open, right? So we want to find the union. So the union means we want to take everything that is in red as well as everything that is in the green one. So what can we do? Already, if you can see what is in the red, it means you go from minus infinity up to where? Up to 3. And that also includes what? The green portion. So it means our final answer is nothing but just from minus infinity up to where? Up to 3 open. So this is the answer. Then let's go for intersection. Now the same question, but now we are interested in the what? The intersection. So let's see how this would differ. So we have minus 3 as well. Here is also 0, here is 1, and here is 3. So the first set is coming from where? Minus infinity up to 3 is open. The second one, it's from minus 3 close to 1 open. Now we are looking for intersection. Since we are looking for intersection, what should we do? Just this part. So this is the intersection that we need. So in this case, we're going to take just what is common, where the red line and the green line meets or intersect. So you can see that in this case, it's going to be, for the green one, you see that minus 3 is closed. Also, when you go to the red portion here, this is the tick line. So it means it is also closed. So it means we can begin our intersection from where? From minus 3 close. But when we get to this point, if you get to 1, you see 1 is included in the red but not included in the green, right? Since you are dealing with intersection, then it means we cannot take 1. So 1 has to be what? Open. Why? Because the green is open at 1, but the red is closed at 1. So if you are looking for intersection, you have open and closed, then you have to take open. But if it is union, then you have to take the closed. So this is from -3 to 1. So let's go to more difficult one. So I think we can just take, let's take 6 before we go back to 1 and 2. So let's take 6. Now, if you look at 6, this is what? X. You see, X is what? X is giving us X. So anytime you see a set like this, and there is no condition on X, now X is not saying X is an integer or X is what? Is a even number or nothing. So anytime you see a case like this, then it means you are dealing with an interval. This is nothing but where? From 3 to infinity. You see? But now let me write this and say like this. Let me say this is X, and I'll say X is what? Integer, and X is greater than 3. You see that these two sets are not the same thing. This one is an interval. It's an infinite set, but this one is also an infinite set. But in this case, what do you start from? It's going to start from, you see, since X is an integer and X is greater than 4, you're going to start from 4, 5, 6, 7, 8, then continuously. So you see there's difference between these two sets. So you have to take note of that. If there is nothing mentioned about your X, then you assume your X is just a real number. So your answer should be an interval in this form. This means from 3 to infinity. But if X is given as an integer or X is given as an odd number, it means your element will be discrete. It's still going to be an infinite set in this case because you are going to 3, greater than 3, but it's not going to be an interval. And I told you the difference between interval and set. Look at the bracket I'm using here. I'm using this curly bracket. Okay. All right, this is just an additional explanation. Now, it's not required here for this question. So now, y, what is y? Y is given as what? X less than equals to -12. So this simply means you are coming from minus infinity, but when you get to -12, you have to stop. But here also 12 is inclusive, so you have to add a close bracket. And what is our interest? Our interest is to find the union. So we're interested in the union. So let's get the number line. So if this is 0, this is 3. So 3 open, going to infinity. And then we have what? We have y, which is going to -12. So let's assume this is -12. And then this is -12 close. Close. Okay. So now this is what? This is set x, right? And this is set y. Now we want to find the union. What is union? Remember, let me just write it here. X union y is simply all the x's that are in x or x in what? In y. So it means take every element that are in x and also take every element that are in what? In y. Don't forget that this will continue. This is also going to where? This is going to infinity. This is going to minus infinity. So If I want to take everything, it means I want to take the whole of X and I also want to take the whole of what? Y. So in this case, the only portion that we're not going to take, the only thing that is not, we cannot take is this part. This part, we cannot take it because it's nothing. There is nothing here. So this part is not included. So it means our union is going to be the whole thing. It's not just going to be from minus infinity to minus 12 closed. Union, well, 3 to infinity. So this is our answer. So the only part that is not included is what? Is the union there, the part you can see in yellow, because we're interested in the union. Now, let's do something extra. What about if we're interested in the intersection, even though it's not asked? So if you're interested in the intersection, you will see the intersection means where the red and the black meet. Do they meet anywhere? No, there is no intersection. So our intersection is just going to be empty set. All right, let's go now to a more challenging one. Now, before we do number 4, let's go to 1 and 2. Okay. So look at 1 and 2. 1 and 2 now, it's this also, you want to write it as a single interval. So you first of all look at this interval. This is like finish with what is in the bracket, then you intersect it with this one. So let's draw the number line here. Now we have 8. So if this is 0, let's say this is 8. This should be 13. And we have somewhere 11 and somewhere 16. Now, if we're dealing with the one inside, let's do that in red. Minus 8 to minus infinity to 8. So coming this way to 8. So this is going to be open. Then we have another one, which is 13 open as well to infinity. Okay, now if you are asked to find this one, let's just say we're interested in this in the inside of the parenthesis. What is the union? The union is going to be the red part and the green part put together. So if I want to write this union, it's still the same. It's still going to be minus infinity, 8 union 13. This is the union. This is the result of this one. There is no other way to write it, right? But we want to intersect, so this is very important. We want to intersect this now with this part. So this intersection with 11 to 16. So let's bring 11 to 16 on board now. So remember, this is 11 close. So it's going to be 11 close. 11 is here. Then we will draw this and we stop at 16, which is open. So we look for the intersection now. Intersection means we're looking for an intersection of both the red, the green, and the what? And the black. And you can see the only portion that there is intersection is this one. So this is our intersection. So let me remove this. And what is this intersection? As you can see, in this area, there is no any intersection, nothing. So here, you don't have any answer from here. So you have an answer here. And you can see in the green, 13 is open, but in the black, 13 is what? Is closed. So since we are looking for intersection, we just take 13 open. Then you get here. Here you can see that 16 is open with the black, closed with the green. So 16 as well will be open. So your answer is 13 to 16. So next is similar question. So here as well, we do same. Zero, we have 1, there is 5, and there is -2. So from -infinity to 0, open somewhere here. Then we have from 5 to infinity, which is 5 open as well, to infinity is still somewhere here. So you can see this is the union. So this is the first set here, right? Then we want to intersect this whole thing with what? We want to intersect it with -2 close, which is somewhere here, up to where? Up to 1, which is open. Okay. So what is the intersection? This is the intersection only. Because for this path, where you have the green, there is no intersection between the black and the red. So this is just going to be from -2 close. Why is it close at -2? Because it is close red -2, also black at -2. And then you have to open it at where? At 0, right? So our answer is just going to be from -2 to -2 close, but 2 is what? 0, 0 is going to be open. So you have this one. So this is the answer. Oh. So now let's go to the next question. See, that is number 3. Let's do number 3 now. This is -2. Now for number 3, it's more like just discrete. I think they're all finite sets. So this one is we just list them. We know what is A, we know what is B. So the only thing that we need to rewrite is this one. You see, C and D, they are given using what we call the set builder notation. So you need to be able to write them out correctly, right? So first of all, let's concentrate on C. A, B, and Y, Z, they are all easy. So look at C. What is C? C says Y such that, what is Y? Please, just to, there's a little bit of correction I did here. So you look at the worksheet I uploaded. So this C is defined as Y such that Y is minus X plus 1, such that X is what? Even. So X is what? Even number, very important. And this X is what? Is between -2 to where? To 4. So what are the even number here? So X is going to be what? So it means that X is -2, 0, 2, and what? And 4. These are the values of X. But C is not just X, C is Y. So it means the C itself is going to be what? You take X, you multiply X by minus, then you add 1. So it means that if X, for example, if X is -2, remember what is Y? Y is minus X plus 1. So this means that you will have 2 plus 1. So which is going to be what? 3. So if X is 0, Y is going to be minus X plus 1. So if you add X to be 0, so you have what? It means it's still going to be 0 plus 1, which is 1. If X is now 2, y is minus x plus 1. So you will have minus 2 plus 1, which is minus 1. And finally, if x is 4, y is minus x plus 1, which is what? Minus 4 plus 1, right? Which is minus 3. So it means your set C is all the y's. So you can say it is 3, 1, minus 1, and what? Minus 3. So this is our set C. Okay, now set X is easy. You can see what is set X. Set X is just all the positive integer less than what? Less than 6. So it means we have to start from 1, 2, 3, 4, 5. Remember, 0 is not a positive integer, right? And I think everything is set. What do you need to do? Just find the union. So for example, here we are interested in A union what? Let's see if we can create some space. A union X. What is A union X? It simply means what is in A and what is in what? In X. So what is our target now? This is where you should be looking at. This is A and this is what? X. So want to find the union, it means you take everything that is in both, is in X or A. So for example, we have 0 here, we can take 0. We can have 4, we take 8, we take 12, right? Then here, what is in X that is not in A yet? So we can take 2, we can take 1, we can take 2, we can even take 3. Can we take 4? Yes, already there is 4, then we can take 5. So you see, in this case, it's not arranged, but you can decide to arrange it as 0, 1, 2, 3, 4, 5, 8, and 12. So either you leave it or this, both are still correct. You don't need to arrange it. So I hope I didn't miss out any time. Okay, now we are looking at A intersection Z. Intersection means what is common, right? What is in both A and in what? Z. So you look at A and Z. What do you have in A that is also in Z? Anything? I think I can see only 8, right? Right. Then also here now we have C intersection Y. So we are focused on C. Where is C? This is C. And Y. Where is Y? Y is 1, 2, 3. So I think we have 1 and 3. Remember, intersection means what is in C and also in what? In Y. All right, so now let's look at B intersection Y. What is B intersection Y? B intersection Y. This is B, and where is our Y? This is Y. B intersection Y, I can see only 3. So now C union Z. It means what is in C and also in what? In Z. So for example, you can decide to take the whole C, which is 3, 1, minus 1, minus 3. Then take the whole Z, which is just what? 6, 7, and what? 8. So you're done. You can decide to now arrange it from smallest to biggest. It's all the same. I mean, you can write it as minus 3, minus 1, 1, 3, 6, 7, 8. All right. Now, finally, A union Z. the same. I thought we did A union Z before. Okay, no, it was intersection. So A union C means take the whole of A, 0, 4, 8, 12, and add the whole of Z, but there is no repetition. So it means you will add 6, 7 only, because already there is 8, which you can rearrange as 0, 4, 6, 7, 8, 12. Hope I did not miss out any number. So you can check. If you miss out anything, you can just put it in the comment section. Now, number 4. Number 4, it's very direct. It said express the sets in interval notation. So here you can see anytime you have something like this, it means open, right? So this is simply saying, it's just like saying open. This is the same thing as open to where? To infinity. So the answer is just what? It's just 10 to infinity. So this is correct. So if you have this, then this means close, right? So this would be closed, but this means open, right? So it's nothing. All right, now, so let's cover something different here. I'll go to question number 7 and question number 8, even though we've not done this yet, but I would like to explain it now. But it's not difficult. You can follow easily. Okay, so question number 7. Question number 7 is asking for simplification. It has to do with absolute values. So let's discuss that briefly. Need to create more space. All right, good. Number 7, we're here now. Now, what is number 7? Number 7 says simplify each expression by writing the expression without what? Without absolute value. Now, what this simply means is that we don't want to have an absolute value again. So, but remember, what is the definition of an absolute value? I will start with an absolute value. An absolute value of x is simply going to be x if the x is what? Positive. Yeah, or you can say if x is greater or equals to 0, then the absolute value of x is x. It is minus x if the x is less than what? It's less than 0. So now all you need to check is you just need to know the sign. So if I have x plus what? 11. Now I want to write this without an absolute value, but I have a condition. What is condition do I have? I have that x is less than what? Minus 11. So what it simply means is that your x, what is the meaning of x less than minus 11? It means your x is between minus infinity to what? To minus 11 open. So it means your x is coming from this interval. So all you need to do to test is you just need to know, you want to know what will be x plus 11 when you take any x from this interval. Is it going to be positive or is it going to be what? Negative. So that is all you need to test. So one easy way to do is just take x. So you can take x to be any number here. You can take x to be, for example, give me any number between minus infinity and minus 11. So you can take any number, say for example, minus 12, right? It's in this interval. Now, if you try minus 12 here, just substitute minus 12 into this, you will have, remember you have minus 12 plus what? 11. Minus 12 plus 11 is a negative number. So it means that inside here, what you are going to have is a negative number. So it means, so don't forget, we're dealing with A part now. I'm dealing with A because for A, we take condition x less than what? 11. Now, if what you have inside the brackets is what? Negative. So just apply the definition. Remember, this is definition of an absolute value. Anytime your x is less than 0 means it's negative. What will be your answer? Just multiply what is inside with a what? A negative number. So since x plus 11 is negative, our answer will just be minus, right? Then just write down your x plus 11. So I'm using this definition now because it is less than 0. And this will be, now take this minus inside. So this will become minus x minus 11. So this is the answer without using absolutes, because you're asked to write the expression without an absolute value back. Now, let's take the second one, the B part. Now, for the B, what is different? In this case, we're taking x to be greater than 11, right? Than minus 11. So that is the condition here. And so let me just do it here. Let me do the B part here. So this is the B part. So for the B part, we also want to write x plus 11 in absolute value. But now, what is the condition? The condition is that x is greater and equal to minus 11. So all you need to do is you need to know what is that. Our x, when we say x is greater equals to what? Minus 11. What does that mean? This simply means that you are from minus 11 close to where? To infinity. So it means you can take any x. It means your x, it belongs to minus 11 to where? To infinity. So I can just use any x to test. So just take any x from here. Look at this. This is closed, right? Since this is closed, it means minus 11 is also in the set. So I can take minus 11. Now, if you take minus 11, you are going to have what? Minus 11 plus 11, which is just going to be 0. But that will not really help us. So we can take another number. So you can take something like what? 0, because you have, this is what you have, minus 11 close to this. So you can take any number here. For example, there is what? Minus 10, there is 0, there is 4. There are many numbers. So just take one. For example, I can take what? I can even take 4. So if you take 4, you add it here. So put x, substitute x to be 4. 4 plus 11 is going to be a positive number, right? So if it's a positive number, it means that here it's going to be positive. Now, since this is positive, then we go back to our definition. Definition is very important. If this is positive, what do? Anytime you have a positive number inside the absolute value, what is your answer? Your answer is just x. Anytime x is greater than what? Than 0 or equals to 0. So it means that the answer to this question is just going to be same thing that is inside the absolute value, which is just x plus what? Plus 11. So finally now, let's talk about question number 8. Question number 8 is one of your recitation problems, so also check your recitation. Now, this case is that you want to write this expression without absolute value. But we have a condition. The condition is this one. It means your x is between what? So let me just write it. This is like saying x is between 1/3 close to where? 2/3 open. Right? So what can we do? Now, what you need to do is that you need to know if what you have here, what is inside the absolute value, if it is positive or it is what? Negative. That is all you need to know first. That is the first thing. Now, how do you check? You take any x from here. So just take any number that is between 1 over 3 and 2 over 3. And that is the number you can use. So, for example, you can see that what this is 1 over 3, right? And now this is what? 2 over 3. So you need a number that is between 1 over 3 and what? And 2 over 3. Yes? So which number can we take that is between? So if you look at this interval, remember 1 over 3 is closed. So it means this is closed and this is what? Open, right? So since this is closed, it means I can even take x to be what? 1 over 3, because 1 over 3 is inside here. So what you do, take 1 over 3, come here. What is 1 over 3 minus 2 over 3? So you have 1 over 3 minus 2 over 3. I'm trying to explain this one. So 1 over 3 minus 2 over 3. You see, it's going to be a negative number. So we're not interested in, we're just interested in the sign, whether it is positive or negative. So now you see that this is going to be negative, right? Also, that same, remember we're taking x to be 1 over 3. So what is 1 over 4 minus what? Minus 1 over 3. Is it going to be positive or negative? Definitely, you know, this is going to be what? This is going to be negative, right? All right. So why is this negative? You can try to use your idea of what? LCD. If you want to do LCD, you can multiply this by 4 over 4, multiply this by 3 over 3. So you will have 3 over 12 minus what? 4 over 12. So this is 3 minus 4 over 12, which is just minus 1 over 12. So it's a negative number. Now, what is important is whether it is negative or what? Positive. So it is negative. So it means that here is going to be negative. Now, this is the first step. So the first step is to establish whether here it's negative or not. And we have done that using this test value. X is 1 over 3. Now we can remove the absolute value. Since this is negative, if I want to remove the absolute value, I have to introduce this negative here. So it will be negative x minus 2 over 3. I hope this is clear. Why? Because I'm using the definition. The definition of an absolute value. Anytime I have negative, if the content of the absolute value is negative, if I want to remove the absolute value, I have to bring the negative down. Okay? Now, this black negative here is still here, so let me put it here. So this negative is still here. Now, this second absolute value, you can see that this is also negative. So now this negative can come down. So I will have also another negative. Then we will have this is 1 over 4 minus x, right? Then now we can finish it. Minus will go inside here. This will become minus x plus 2 over 3. This minus and this minus makes this to be positive. So you just have positive 1 over 4 minus x, right? So this will be minus x plus 2 over 3 plus 1 over 4 minus x. See? So what will be these numbers? Minus x. This and this one will give us minus 2x plus 2 over 3 plus 1 over 4. So you have 2 over 3 plus 1 over 4. Here also you can try to make the LCD the same. You can multiply this by 3 multiply this by 4/4. So we're going to have 8 plus 3, which is going to be 11 over what? Over 12. So we can write this as 11 over 12 minus 2x. So it means the answer is what? Is C. All right, so we'll take more of these examples maybe in class as well. If you have any question, you can write it in the comment section. So for those of you that are yet to subscribe, so kindly do that and turn on the notification bell so that when I upload videos, you can easily be notified. Thank you for watching.